Assalamualaikum and hi everyone. My name is Umi Sarfina bint Rosmati with metric DE180116. I will presenting about the adaptive position control of brush-based PV cleaning system by analyzing DC motor. So the research team consists of me, Umi Sarfina, my supervisor, Dr. Syed Zahurul Islam, and my co-supervisor, Dr. Nur Hamiza. The presentation outline consists of introduction, problem statement, objective, scope, flowchart of brush controller, circuit diagram, preliminary result, future plan and references. The slide is labeled accordingly. Since the production of fossil fuels such as gas, oil and coal are expensive, limited and difficult to store and also contributes to global warming, the availability of the electrical energy has become increasingly crucial for nations' development. So, sustainable energy has attracted many attentions in achieving greener energy solution. That shows the usage of PV not just increase in Malaysia but all over the world. So, the energy generated by a solar panel is directly proportional to the amount of the sunshine that falls on it. So, we can conclude that the more the sunshine falls on the solar panel, the more the electricity it generates. The biggest problem is the PV often placed outdoor where it can be contaminated by bird dropping dust, which lowering PV production efficiency. So according to the previous study, the solar panel cleaner, which is an automatic system that cleans the surface of solar panels, and when it is installed on commercial solar panel array, the system is expected to boost energy production by 10% on average. This prototype has the same as the robotic application, which consists of sensor, motor driver and microcontroller. So next, for problem statement, the PV panels usually installed at high places such as rooftop or even in solar farm and much more bigger according to the country's standard angle. So cleaning of the PV could be a danger to human, which lead to staff accidents and health problems such as asthma, wheezing and difficulty of breathing. So next, there are limited study on the specification of the motor used for the PV cleaning system, limited study on what optimum speed to implement for this system. I conduct a study on motor specification as to know which is suitable for this brush controller mechanism. So the objectives of this project is to develop algorithm for controlling the motors, which will be working as a fully autonomous PV cleaning brush controller. Next is to implement the DC motor driven brush controller incapable of withstanding the weight and movement during cleaning. And lastly, to analyze the motor rating, torque and speed for brush movement of the brush controller. So for scopes of this study, this research only limited to supply the movement of the brush controller and the performance of the motor. Cleaning, sensor and specification of brush had been completed by Zurin Atira as my partner in research. So the automatic cleaning system is designed by microcontroller that embedded with motor drivers, limit switch and motors. So the coding are pre-programmed to a microcontroller where it is built and designed in the Arduino IDE and send the signal to the motor drivers and motor to execute the cleaning system. Next, the implementation of the motor are based on its application where the system should move 4 motors simultaneously with 2 different types of movement, which is translational and rotational motion. The motor suitability should be able to withstand the weight and exert sufficient force while cleaning. The force exerted by the motors can be monitored when the circuit is assembled, and the movement of the motor can be observed through simulation and hardware design. So lastly, the performance of the motor is measured in terms of motor rating, torque, speed and price of the motors. The parameters mentioned is important in determining the suitable motors to move the brush with suitable speed and adequate torque for the motors to withstand the weight of the brush. So here is the flowchart of the brush controller. The mechanism starts when the cleaning brush is in its initial position. After that, the microcontroller will check the reading whether LS1 and LS2 is high and low respectively. If not, it will send the signal to notify that the cleaning brush must be in its initial position. If yes, proceed to send signal to microcontroller and both motor driver 1 and motor driver 2, and then the motor 1 and motor 2 will move forward along the PV, while motor 3 and motor 4 will clean the PV while using the brush attached to it. After that, microcontroller will check whether the LS1 and LS2 is low and high respectively. If no, the motor will keep move forward and cleaning the PV until it reaches the limit switch 2. And then proceed to send signal to microcontroller and both motor driver 1 and motor driver 2, which causing the all 4 motors to move reversely, which is counterclockwise. And then proceed to, if the brush in its initial position, which is at the limit switch 1. If no, the motor will keep moving until the limit switch 1 is hit. So for the circuit diagram, there consists of two elements, which is brush controller and edge detector. Motor driver 1, which consists of motor 1 and motor 2, are responsible for translational motion, which move along the PV, and motor driver 2, which hold the motor 3 and motor 4 for rotational motion, which attach to the cleaning brush. So both of these motor driver will embedded to the microcontroller, and two limit switches act as edge detector, which will be attached on the top left and top right of the PV panel. So, and then this system will connect to the cloud storage and data storage, which is done by Zurin Azatira as my partner in research. So for the preliminary result, I've done a simulation test which is done on Process software. So here is the connection. Consists of our Arduino Mega 2 motor driver, which is the same model as the hardware design, 4 motors, 2 switches, and LCD display. Due to limitations, the Process software could not display the motor movement, which I need to display it through the LCD display. So here is the connection of the LCD display to the microcontroller, and the connection of the motor drivers, limit switches, and motors to the microcontroller and both motor driver. So here is the result of this simulation. The limit switch 1 is heated. Both translational and rotational move forward until the limit switch 2 is heated, which causing the motor translational and rotational motor move reverse, which is counterclockwise. So here is the circuit test where there is two different circuits. First is the motor circuit and the second one is the limit switch circuit. The motor circuit is monitored by the light of LED, which is when the coding is uploaded to the microcontroller, causing the motor to reverse, which leads to the LED yellow to turn on, and then the motor move forward, which lead to the green LED to turn on. This also can be observed through the serial monitor in Arduino IDE. Next is for limit switch circuit, where it consists of two limit switch monitors through the two LEDs, which is yellow and green LED. So when the coding is uploaded to the microcontroller, the limit switch 1 will causing the yellow LED to turn on. When limit switch 2 is turned on, the green LED is turned on. So here is my Gantt chart for PSM1, which I successfully achieved and followed. So here is my future plan, which is upgrade the algorithm to state machine system, develop algorithm encoding to combine both systems together, system rectification and troubleshoot after the combined system, collect data of the motor performance and proceed to the report writing. All of these future plans are based on this PSM2 Gantt chart. So here is my few of the references when I conduct this research. Okay, so we proceed with video of motor circuit, which consists of microcontroller, motor driver, and two motors. This video shows that the motor move accordingly, which is clockwise and counterclockwise. As you can see from the movement of the wheels attached to the motors are forward and reverse, which known as clockwise and counterclockwise respectively. The changes are at 2 seconds each. This also can be monitored through serial monitor of Arduino IDE. Okay, next is the video of the limit switch, which consists of two limit switch connected to two different digital pins of Arduino Uno. The activation of the limit switch can be observed and monitored through the color of the LED. So referring to this clip, the two limit switch are connected to two different pins on Arduino Uno. When limit switch 1 is turned on, the yellow LED will light up. Same goes to the limit switch 2, which causing the green LED to light up. That's the end of this presentation. So thank you for your time.